Hi everyone, we are back with one of the very good session on signal and system. So this is going to be lecture number 3 where I will be talking about some of the problems, right? तो आज के सेशन में हम लोग क्या करने वाले हैं? Whatever we have been learning till now, in signal and system, we are going to solve some of the problem from Oppenheim. Okay. Before that, whatever we have discussed in the last session, I'm going to recap as well, right? So already we have discussed the definition of signal. We have seen the definition of system. Also, we have seen that the classification of signal and system, right? The classification we have seen, as well as like we have classified signal as analog and digital signal. Then we have seen the energy signal and the power signal. We have seen the definition as well, and we also developed the concept of periodicity, है ना? तो हम लोग देख चुके हैं कि पीरियड कौन सा सिग्नल पीरियड होता है, okay, and what are the criteria, right? So today we'll see some of the question as well. Okay, before I jump to Oppenheim problem, so I will take some of the problem from the exercise and then we shall solve some of the problems, right? So, and rest of the problem you have to also try. Okay, so let us talk about uh, you know let us recap the concept called periodicity, right? So we need to understand when signal can be periodic, when signal cannot be periodic, and what are the criteria. Okay, what are the criteria? And also we have seen the signal, energy signal and the power signal. So we'll take some question and we will apply those definitions of energy signal as well as the power signal. Perfect. Okay, so yes. So we will discuss here the periodic signal, right? So let me resize myself. Okay, perfect. So today we will discuss the periodic signal, and already we have seen what is periodic signal and what is the criteria for discrete time periodic signal. But suppose we have got a signal x of t, which is a combination of x1t plus x2t, plus x3t and so on and so forth. Okay, or you can say, we have got in discrete time domain. Okay, discrete time signals are given like combination of x1 plus x2 n plus x3n, okay, and so on and so forth. So how do we determine the fundamental they will ask question from determine fundamental period, okay, or you can say they might ask, this is first question they might ask, and they might ask fundamental frequency, okay, fundamental frequency. So if you are able to find the fundamental period or fundamental frequency, then anybody can find the period, okay, and vice versa. Okay, so let me go ahead and take some question here based on that. Okay, so what are the step of finding the time period of fundamental time period, you can say, of time, continuous time signal? Okay, a combination of x1, x2, and x3 and x4, right? So let me write the steps here. So these are the algorithm, that we have to follow, okay, or you can say steps. So number one is going to be, okay, you can say steps finding the time periods, okay, a fundamental time period, you can say, okay. But before finding the fundamental time period, you need to also check that whether the given signal is periodic or not, right? Given combination of periodic signal is periodic or not, right? So let me, first of all, you have to find the time period for T1 and T1 and T2 and T3 and so on, right? So for X1T, you have to find the time period, T1, then X2T, you have to find the time period T2. Then what you have to do, the second step is going to be, you have to test, okay, you have to find T1 by T2, then you have to find T1 by T3 and T1 by T4 and so on and so forth, right? So what you have to do first, whatever time period you have got in the first x1t, okay, you have to take the ratio, okay, and the third step is investigate, okay, or test, okay. Okay, in the second step, whatever ratios you have found, okay, if all the ratios, okay, if all ratios, okay, in, you can say, in second step, or is found to be rational number, right, is found to be rational number. Okay, rational number. What is the meaning of rational number? Rational number is nothing but the ratio of integer. Okay, the ratio of integer is known as rational number. Okay, ratio of integers. Okay, so you can say p by q form is the rational number, where q should not be equal to 0. That also you have to make sure. Okay, so rational number is nothing but ratio of integers. So you have to first find the individual time period. Okay, then you have to take the ratio of t1 by t2, then t1 by t3, t1 by t4. Okay, then you have to test if all the ratios in second step, okay, is found to be rational number, right? Then you can say that then overall uh, signal is periodic. Overall signal is periodic. Okay, this is for sure. You have to do this, right? In case of continuous time signal. So these are the steps which you have to perform, and you can then, at the moment you have investigated that the given overall signal is periodic, then you can find the fundamental period. So fourth number one is going to be the fourth step will be you have to take the LCM of denominators of second step. Okay, find the LCM of denominator of the second step, and the fifth is fundamental period. Okay, fundamental period you can determine directly then by taking multiplying LCM for whatever you have got from the for this T1. I hope this makes sense. So these are the 5 steps that you have to perform always. Okay, so T1, T2, T3, T4, T5, T6, then you have to take the ratio, and then what you have to do, okay, then you have to make sure that you have to investigate, okay, whether the signal is overall signal is periodic or not. So let me take one question here so that you can apply these number of steps. So the question here is, suppose we have got by 1 t equal to cos 50 pi t plus sine 60 pi t. Okay. Now the question is investigate whether it is periodic or not, and then find out the time period. Okay, or you can say fundamental time period or fundamental frequency, right? So here from here you can find the T1 first. So T1 is going to be T1 will be equal to what will be T1 here? T1 will be equal to 2 pi by omega. Omega is 50 pi, and then T2 you can find from here. This is going to be 2 pi by omega naught is, I mean, omega 2 is 60 pi, right? So T1 you have got is 1 by 25, right? And T2 you have got is 1 by 30. Right, now this is the first step that you have to perform. The second step is what? You can find the ratio of T1 and T2, because there are 2 signals only. The combination of 2 signal is given as by 1t, right? So the ratio is going to be 30 by 25. Okay, that comes out to be 6 by 5. Okay, and this is basically the rational number. Okay, this is the rational number because ratio of integer is known as rational number. Okay, then what you have to do, the moment you have seen this, the third is check whether it is rational number. Yes, it is periodic. Okay, the moment you know that the overall signal is periodic, what you can do here is you can find the fundamental period, right? The fundamental period is going to be LCM of second step. See, only one ratio is there, the T2 is going to be the LCM. So T2 means 1 by 30 into T1. T1 is what? Oh sorry, not 1 by 30. LCM is 30 only, right? Okay. So you have to take the 5 is the LCM here, 5. Okay, because T1 by T2 means 5 is the LCM, 5 into T1, right? So T1 is nothing but what? T1 is nothing but 1 by 25. So overall answer is 1 by 5. Okay. This is one way of finding the fundamental period, right? This is one way of finding the fundamental period, and there is another step. This is one way of finding the fundamental period. The method number second, which I always prefer, is if you know that by looking at the signal, you can claim that yes, it is going to be the periodic signal. How? Because if this is given in the form of like this, like cos, uh, 2 pi, okay, mt plus sine 2 pi nt, like that, okay. If it is given like this, okay, provided these m and n should be it is integer, or if both are okay, they're not integer also, okay, but ratio should come out to be ratio number, right? So make sure that if it looks like that, then what you can do here is always go for GCD concept, right? GCD concept. What is GCD? GCD is nothing but greatest common divisor, okay. So to evaluate why we are going for GCD, to find the fundamental frequency. The fundamental frequency, okay. So you see here we have got by t equal to, what was the question here? By t equal to cos t pi t plus sine 60 pi t. So what is omega 1? Omega 1 is nothing but 50 pi, okay? And from here we can find omega 2 equal to 60 pi. Now you can find the GCD of GCD of omega 1 and omega 2, right? The fundamental frequency omega naught is going to be the GCD of omega 1 and omega 2, okay. If it is confirmed that this is periodic, so by practicing many problems, you will be able to figure it out whether it is periodic or not, okay. You don't have to all the time perform those steps which I have told you. I hope this makes sense, okay. So GCD of omega 1 and omega 2, so you write here GCD of 50 pi and 60 pi. What is GCD? Greatest common divisor. So pi will come out, and you can say that 10 will come out. So 10 and 5, 6. Okay. These are the harmonics. You can say 5 and 6 are the harmonics. So the GCD of omega 1 and omega 2 you have got. So from here you have evaluated the fundamental frequency. And if you have got the fundamental frequency as 10 pi, so what is the time period here? The fundamental time period. Okay. In the exam, they will ask a fundamental time period. Okay, fundamental time period. Okay, this kind of question you can expect for 1 mark basically, but concept is very important because the same concept will be also applicable when we will study the Fourier series. Okay, because we always evaluate Fourier series for periodic signal, right? So this concept is very important. So it is going to be omega 2 pi by omega naught. So you can say that 2 pi upon 10 pi, which is 1 by 5. The same answer we have got here as, right? So GCD concept you can use to find the fundamental frequency. Okay. So I hope this makes sense to everyone. This was very important to understand, and let me take more problems here. Okay. So suppose we have got this question like this. Okay. Suppose we have got by t equal to e raised to power j2 pi t by 6 plus e raised to power j pi t by 3. Okay. So we have been given this signal. Okay. So from here also you can evaluate the omega naught. So from here it is omega 1 is basically 2 pi by 6, right? As this is a complex sinusoids, so from complex sinusoids you can compare e raised to power j omega naught t. So this omega naught is going to be omega 1 here, and this is omega 2. From here omega 2 you can find that is pi by 3. Now we can find the GCD. Okay, now we can find the GCD. So I think GCD anybody can find out here. So okay, so for omega naught GCD is going to be 2 pi by 6 and pi by 3. Okay. So once you will solve the GCD, so you will get GCD here as pi by 6. Okay. The GCD will get here as pi by 6. Next, okay. So you can find the T naught, the fundamental time period, that is 2 pi by pi into 6. Pi gone, so answer is 12 seconds, right? So this is how we can evaluate. Okay, this is how we can evaluate. Okay. So what I have told you in the last session is, if it is continuous time signal, right? So you don't have to become cautious, right? You can always find the time period. But in the gate examination you have to be little cautious, okay, for discrete time case as well as continuous as well, okay, because if you look at the PYQs, so you will find which one is periodic, which one is not periodic. Okay, so perfect. So let us go ahead and talk about okay. So I'm looking at your comment as well, if somebody will be live or they might watch after the session as well. I don't have any issue, so people can watch after the session as well, right? Okay, so perfect. So let me take one more question here. Suppose the question is of this kind. Okay, so pi of t equal to sine 2 pi t upon 3 and cos 4 pi t by you can say 5. Yes, it is 5. Yeah. So like this question is there, like by t is there, right? So it is given as product of two different cosines, from this you can say product of two trigonometric function from the different family, sine family and the cosine family. Now you can convert them into addition, right? So what is 2 sine a cos b, right? So you have to apply here 2 sine a cos b. So this is where everybody gets stuck, because see, we are not able to recall what is 2 sine a cos b, right? This is very important to remember. So if you you can write this as, right? So sine you can say sine a plus b or sine a minus b. Okay, sine a plus b and minus sine a minus b. So it is here 2 is not multiplied, so you can say 1 by 2. Okay, sine a plus b minus sine. Okay, so it will be like this. So what is that? So 2 pi by 3 plus 4 pi by 5, right? So can you add here, right? Because I don't know what is the addition. 2 pi by 3 plus 4 pi by 5. Okay, so what is that? 15, and this is 10 pi plus 3, 12 pi, so it is 22. Okay, 15t, and subtract it, so it becomes sine a minus b, right? So okay, so I think this is fine. So I can also check whether sine a cos b is what, right? What is sine a cos b? Sine a cos b is nothing but, yes, sine a cos b is nothing but sine a plus b plus sine a minus b. Sorry for that, this should be plus here, right? So it will be plus sine. Okay, remember, so sometimes it in fact I also make mistake, right? So sine a plus b plus sine a minus b, but in case of periodicity this plus and minus does not matter here. Okay, what matters is you should be able to find the corresponding radiant frequency, then you can go for GCD, and then you can find the fundamental frequency, right? Because this plus minus, we have to only take care of the argument. Okay, that is what you have to make sure, right? And the argument that matters, which will help you to find the fundamental time period. Okay, So this is 2 pi t by 3 minus 4 pi t by 5. Okay, so if you see here, it will be minus of that. So from here you can find omega 1. Omega 1 is going to be you can say 22 pi by 15. Okay, and from here you will find once you will subtract, so it becomes 2 pi by 15. Okay, so omega 2 is going to be 2 pi by 15. Okay, now what you have to do, you have to find the GCD. GCD means greatest common divisor. So GCD of 22 by 15 and 22 pi by 15 and then 2 pi by 15. Okay, so what is omega naught here? So omega naught you can find out is 2 pi by 10. Okay, 2 pi by 15 will be the omega naught. Perfect. So this is omega naught, and then you can find the fundamental frequency, fundamental time period. This is 2 pi into 15. So this goes, T naught is 15. So it is not that difficult problem. I think anybody can solve this. Very simple one. Okay, so this is how we find the time period. Okay, and suppose we have got a question like this. These questions you can find from the Oppenheim only. So I'm taking question from Oppenheim now. So xt equal to e raised to power minus 2 plus j3 t. Okay, though I haven't taught till now is some of the standard signals. So these are the some standard signals. So before you determine the whether it is periodic or not, first you need to take care, you need to split this, right? So 2t dot e raised to power minus j3t, right? Okay, yes. So I hope this makes sense. So this, because of this guy, this is not periodic. Okay, remember, this is not periodic. This is not periodic. If it is not periodic, then you can say that overall is not periodic. Okay, overall signal is not periodic. Okay, if it is not periodic, then you cannot find the time period. Okay, so in order to evaluate the fundamental time period, you should know that how, whether it is periodic or not, right? That you have to make sure. Okay, and suppose in the exam they have asked the question of this kind, find the periods, okay, whether if it is periodic, if j e raised to power j10t, right? So I hope this makes sense. You know, this j is basically e raised to power j pi by 2. Okay, so okay, so this is the additional phase. This is the additional phase here. Additional phase. Okay, so j means e raised to power j pi by 2. Okay, and if this is the additional phase, right, if it is an additional phase, so it never changes periodicity. Okay, this you have to remember. Okay, additional phase never changes periodicity. Okay, phase change means what? In signal and system you will come to know that phase change is equivalent to shift in time. Okay, or you can say time shifting. Okay, if you are shifting in time, you will always get phase change in frequency domain, right? In signal system you will see this. This is very important concept. Okay, so phase change is not going to change the periodicity, you know, because you are shifting in time, so the time period will be same only, right? Shifting does not affect. I hope this makes sense. So you can find omega naught is 10 and t naught is basically 2 pi by 10, so it is pi by pi by 5. Okay, so I hope this makes sense to everyone. that you have to take care. Perfect. So now we will see some of the standard signals, because understanding standard signal is very important. Then we will solve question based on signal, energy and power. Okay. Some of the standard signals. Okay. So keep this in mind. You guys can solve more questions. Okay. More questions from Oppenheim. Okay. Oppenheim exercise. Right. And then go for PYQ. So you will be able to like you will gain a lot of confidence, because this book is very important to be done. Okay, all the exercise problem I would say, right? Chalo. Some problem I am solving, but most of the problem you have to take care. So some of the standard signals. The very first is the unit step function. We call it unit step function or unit step signal also. Sometimes we also call it Heaviside function. So what is the formal definition of unit step function that you have to keep in mind? Unit step function is defined as u of t. Okay, this is the formal definition I'm telling you. U of t is 1 for t greater than 0. Okay, that you have to make sure this is strictly greater than 0, not loosely speaking equal and greater than 0, right? So u of t will be 1 for t greater than 0 and it is 0 for t less than 0. यहाँ पर आपको ध्यान देना है, ठीक है, ये स्ट्रिक्टली ग्रेटर है. So unit step function means what? U of t is defined, okay, u of t is defined for it will be 1 for t greater than 0. Yeah, I hope this makes sense to everyone. Okay, and yes, I think my voice and everything is okay. I need to check also, because today I haven't checked, so whether it is okay or not. Yeah, it is perfect. Yeah, it looks good. So now what we are going to do here is remember ut, this is 1 for t greater than 0 and this is okay, so this is strictly greater. Okay, so this is how unit step function is defined. Okay, unit step function is defined. So I hope this makes sense. And how to graphically represent this? So u of t is going to be 1 for t greater than 0 and 0 for t less than 0. Now this is u of t. Okay, so what they have said here is that they have said for t greater than 0, so we always represent approximated approximated function. Okay, though it will be looking like this, because the moment you start something, right, it is not possible directly you will reach at t equal to 0 1. Okay, that you have to make sure. So it starts like this and goes like this. Okay, but what we can do here is we can approximate this. Okay, so we need to approximate this. Okay, so the approximated one will be like this. Okay, so this is u of t. Okay, so it is defined for t greater than 0. It means it is defined for positive time. Okay, it is defined for positive time. And keep in mind that in signal and system we always take u of 0, okay, is equal to basically 1 by 2. Now the question is, how do we determine u of 0 equal to 1 by 2, right? Because you know that this is discontinuous, okay, at t equal to 0 here. Okay, so u of t it seems like that at t equal to 0 it is 1, right? But it is not the case, right? So from the former definition, you have to take care, okay, that u of t is 1 for t greater than 0. U of t is 1 for t greater than 0. Okay. Okay. So this is approximated one, right? Approximated. Okay. Because something, if you start, so it will start like this, then it will settle down. Like it's very small, right? So how do we determine this? Suppose we have got the u of t. U of t is nothing but this. Okay. X of t be equal to u of t, right? Now we always, whenever we want to find, and this is a discontinuous function, right? U of t is highly discontinuous around t equal to 0, right? So we go for Gibbs phenomena. Okay? That phenomena is known as Gibbs phenomena, right? Gibbs phenomena. Okay. So what Gibbs phenomena says that if you want to find x of 0, so what you have to do always is you have to take the average of the two, right? Whenever there is a discontinuity, okay? So it will be 0 minus plus x of 0 plus upon 2. What is 0 minus? 0 minus is just before t equal to 0, and t, what is 0 plus? Just after t. Okay. So this expression we will always use whenever there will be discontinuity about t equal to 0, right? So in order to find the value at t equal to 0, you have to go for Gibbs phenomena, right? So suppose we have got the situation of this kind. So this is 1 for, okay, t greater than 0. So what is at t equal to 0 minus? This is 0 here. You can say at t equal to 0 plus, it is 1. So you can find u of 0 equal to u of 0 minus plus u of 0 plus upon 2. What is this? This is 0 plus 1 by 2. So you can say that u of 0 is going to be, u of 0 is going to be always 1 by 2. Okay. So this is u of t. Always keep this in mind. Unit step function. Unit step function. Okay. So suppose we have got the signal of this kind, exponential signal, you can say. Suppose xt is given as e raised to power minus t, right? Like this. So this signal will be going from like this. Okay, it is decaying exponentially, you can say. If you put t equal to 0, so it becomes 1, and minus infinity and plus infinity, right? So it is just like a decaying exponential, and you can realize this by taking the example of what? Population of not population, you can say, right? Because population is growing, okay, exponentially growing. It is exponentially decaying. Your knowledge, you can say, right? If you don't study for 1 week, your knowledge goes down. Okay. So but if you multiply this x of t with ut, so the signal will start like this. It will start from here onwards, right? That you have to make sure, because everything will be 0 in the for negative side. Okay, because you are multiplying, so it is not 0. Okay, you are multiplying two signals. This signal is defined for negative value of time as well, but this signal is not defined for negative value. So 0 and something non-zero, it becomes 0 only, right? I hope this makes sense to everyone. Okay. So this is one important definition of unit step, and from unit step you can also get second kind, okay, that is named as rectangular function. Rectangular function, okay, or you can say rectangular signal. So rectangular signal is nothing but, we always write with the help of definition, a rect t by capital T. Okay, a rect t by capital T, which is defined like this. Okay, it will be a for t greater than or equal to, like this, and it will be 0 otherwise. Okay. So A rect T by T. So what is this capital T? This capital T is nothing but width of rectangle, and this A is the amplitude or height, you can it. Okay, this is very important to understand. So we can also, write it. Okay, you see here, A rect T by capital T is defined as A for mod T less than T by 2, and it is 0 otherwise. Okay. So again and again, if you write this, okay, so you will be able to recall. So we can graphically show this. Okay, it is A for between T by 2 to T by 2. Okay, xt. Sorry, this is time. Okay, so your A rect T by T is what? A rect T by T is nothing but A for mod of T less than or equal to T by 2, right? So what is the width here? Width is going to be, and this is the height, or you can say breadth, right? So you can say this is length and this is breadth. Okay, T by 2, and this is A from here to here. So you can also find the area of this. Okay, what is area? Area is, sorry, this will be T, not T by 2, it is T. Okay, so what is area here? The area of this rectangle, okay, area of this rectangle is 80. Area of the rectangle is 80. Okay, so this is how A rect T by 2, A rect T by T look like. Okay, suppose I give you 2 rect T by 5. Okay, so can you plot this? Yes, you can plot like this. It will be half of that. Okay, so this is total width. Okay, so half of this is 2.5, and this is 2.5, and this would be 2. Okay, if you take the, if somebody will ask what is the area of this, area of 2 rect T by 5. So how to determine? Just take this and take this. Okay, 2 into 5, that is 10. You can, in fact, you can also find from here what is the length here, or a breadth, you can say. The width is going to be 5. Okay, and 2 is the height here. So 2 into 5 is 10. Okay, this is the area. Okay, now if I write here, suppose in the exam they have given rect T by 10. So find the area of this. So what is the area? Area of this is going to be 10 only. How? You can plot it. Okay, so what is the plot here? This magnet, this height is going to be 1 only, right? And what is the half of 10? That is minus 5 and 5. Okay, because this 10 denotes the total, you can say, breadth. Okay, so this is how while finding the Fourier transform and all, you will be needing to plot and quickly find out, right? In fact, while finding the energy and all, right? So this is very important concept that you have to keep in mind. So let me take one question here. In fact, suppose we have been given a signal by t, okay, e raised to power minus 2t ut, and they're asking find the energy of the signal. Find the energy of the signal. It is very easy question though. Okay, so how to find the energy of by t? Okay, how to find the energy of by t? So we can apply the definition first, right? So the definition of energy signal is basically energy, minus infinity to infinity. First of all, we have to take the by t mod and then take the square dt, right? So can we take here? Yes, minus infinity to infinity e raised to power minus 2t ut, okay, whole is multiplied with e raised to power minus 2t, right? If this ut is present, it means it will start from after t equal to 0, means this ut is defined for positive time, right? So this limit of integration will also change. Okay, this limit of integration is going to be starting from 0 to infinity right now. Okay, and you can write this as e raised to power minus 2t square dt. What is this? You can write this as, I think, 0 to infinity e raised to power minus 4t dt, because you know that a raised to power m to the power n is what? A raised to power m times n. In the same manner, we are trying to write, because most of the students make mistake here as well, right? So by t equal to e raised to power minus 2t ut is given, right? So we can directly find the energy. Energy will be 0 to infinity e raised to power minus 2t whole square dt. Don't forget to take the square of that, okay? You can write this as 0 to infinity e raised to power minus 4t dt. Now you can integrate it, so it becomes e raised to power minus 4t upon minus 4, 0 to infinity, right? If you put infinity here, so it becomes 0, and if you put 0 here, it becomes 1. So answer will be 1 by 4 joule. Okay, so keep this very important. Okay, so suppose you have got the signal of by t equal to e raised to power minus 80 ut, and it has the energy E. Okay, it has the energy. What will be the energy here? It will be having the energy 1 by 2a, because you see here whatever power was there, it was 2, so energy is 1 by 4. So this shortcut also you can keep in mind. Okay, suppose somebody will ask you that what is the energy of pi t equal to e raised to power minus 5t ut. So the energy is going to be 1 by 10 joule. Okay, just you have to multiply with this a 2, okay, 2 times a. I hope this makes sense. And this energy is finite, okay? Then you can say that this is an energy signal. Okay. So I have discussed about ut. Ut looks like this. Okay, so what we are going to do here is we'll discuss more standard signal, okay, in the later session, in after this session, okay, and we'll take more problem. For this this will be enough here, okay? So we are going to wind up the session here, right? So we have discussed some of the problems, and we'll take more problems, and we will discuss more standard signals, okay? And in the next session, we are also going to talk about the operations of signals, right? How to add signals, you know, how to subtract signals, you know, two signal, how can we subtract? We'll take rectangular functions, okay? Rectangular functions are also known as window functions, okay? Because they are defined for certain time duration, okay? They are a finite duration signals, okay? That's why we also call them as an energy signal, okay? So this will be our story, okay? So in the next session we are going to meet. For today I think this is enough. I've discussed many things, right? So I started with the you know, the periodic signal, and I have given you the step-by-step calculation how to find fundamental time period. So one question was there in GATE 2013. They have given the combination of signal and they ask you to determine the fundamental frequency. So it was very easy question too, right? Because if I think I can recall that question as well. Xt was given as cos 100 t plus you know, cos 200 t plus, you know, sine 300 t, okay? So they asked you what is the fundamental time period, not time period, they asked you to fundamental frequency. What is the fundamental frequency? Just you determine here omega 1 100, omega 2 200, and omega 3 300, right? What is the fundamental frequency? Omega naught equal to GCD of omega 1, omega 2, and omega 3, right? So what is going to be here? It is very simple then, right? So it is GCD of 100, 200 and 300. So what is greatest common divisor? That is 100 only. The answer is 100. So they ask this kind of a question. You might expect for 1 mark, in fact, right? I'm telling these concepts will be asked for, also asked for 2 marks, right? So please keep this in mind. And now we will start playing with the signal, okay? The next class, we will start playing with the signal.